Okay, so this question asks the equation x squared plus y squared plus z squared plus 2x minus 4y plus 6z equals c, and it is a sphere of radius 2. What is c? Okay, let's write it first. X squared plus y squared plus z squared plus 2x minus 4y plus 6z equals c. So you see x squared plus 2x, so let's write it down together. And y squared plus minus 4y, so let's write them together as well. Same thing, c squared and 6c, let's write them together. So when you see all of this x squared plus 2x plus y squared minus 4y plus 6z squared plus 6c, you can group them as like x plus 1 squared, like completing the squares. Plus y minus 2 squared plus c plus 3 squared. This will give you x squared plus 2x plus 1 plus y squared minus 4y plus 4 plus z squared plus 6c plus 9. Which in here, if you compare this line and this line, there's only difference between those two is just, the difference between those two equations are just, there's like numerical values, 1 for 9 added, other than just 2x, x squared plus 2x, and y squared minus 4y, and z squared plus 6z. So what we do is, when you have this equation, x plus 1 squared plus y minus 2 squared plus z plus 3 squared, you add 1 for 9 plus 1 plus 4 plus 9 to make it equal to each other and cancel out. So if you write it again, x plus 1 squared plus y minus 2 squared plus c plus 3 squared equals c plus 14. And then we're given that the sphere is a radius of 4. So c plus 14 should equal to 4, meaning c should be negative 10. So the answer for this question is E. Okay, so this question has find projection of W onto B. When you want to find projection of something onto B, what you do is W dot B over B dot B dot B. So basically when you have projection like A onto B, you do A dot B over B dot B dot B. So same logic. You do WB over B dot B dot B. So when you have that, this W is 1 negative 2 3 dot 2 3 6 over 2 3 6 dot 2 3 6 dot 2 3 6. If you do calculation, the numerator becomes 2 minus 6 plus 18, 4 plus 9 plus 36, 2 3 6 multiply. This just becomes 14 and 49, 2 3 6. So this cancels out as 2 over 7, 2 3 6. So this just becomes 4 over 7, 6 over 7, 12 over 7. So the answer for this question is D. Okay, so this question asks which of the following statements are true. Let's look at it. Number 1, 2i and j plus k are orthogonal. So you can write 2i as 2, 0, 0, and j plus k as 0, 1, 1. If you want to find their orthogonal, what you do is you dot of those two vectors, and when you check the dot product of the vectors are equal to 0. So if you do the dot product of this becomes 2 times 0 plus 0 times 1 plus 0 times 1. So this becomes 0, 0, 0. So the dot product of this vectors are equal to 0. So 1 is right. Let's look at the second one. The B is a 3-dimensional. Let's write B as like, I don't know, randomly we can write it as like 1, 0, 1. Let's do cross multiplication of B. I, J, K, 1, 0, 1, 1, 0, 1. This becomes 0, 0, 1, 1, I minus 1, 1, 1, 1, J plus 1, 1, 0, 0, K. If you do the cross multiplication, this becomes 0i minus 0j plus 0k. So this all becomes 0, so it becomes a vector 0. So that is right. So 1 and 2 are right. And then let's look at the third one. If w is a vector, w dot w equals w magnitude. So if you remember your dot product properties, if you dot the two vectors like w dot w, this should become w magnitude squared instead of just having w. This is just a property that you should memorize, so that's that. So this is not right. It should be the squared value of magnitude. So 1 and 2 are right, meaning the answer for this question is A. Okay, this question asks A magnitude is 4, B magnitude is I plus 4j plus AK, and the angle between A and B is pi over 6. And they're asking A cross multiply B magnitude. So when you're given A cross multiply B magnitude, this can be written as A magnitude and B magnitude and then sine theta. That's the equation that you have to remember when you're given the angle between the vectors, especially with the cross products. So we are given A is 4, there we go, and B magnitude, we are not given the B magnitude. Let's find it then. B magnitude is square root of 1 squared because I is 1, plus 4 squared because J is 4, and then A squared because K is 8. And then you multiply and you do the calculation. 1 plus 16 plus 64, this becomes 81, so this becomes 9. 4 times 9 times sine pi over 6. So, and that should equal to that value. So 36 times sine pi over 6 becomes 1 over 2. So 36 times 1 over 2 is 18. So the answer for this question is E. So this question asks the area between the curves y equals x squared and x plus y equals 2. Let's write it, y equals x squared and x plus y equals 2. And this equation can be written as y equals 2 minus x. Now let's draw it. Y equals x squared like this. And y equals 2 minus x, 2, 2. And then let's draw it a little bigger like this. And 2, 2 like this. This is a little slanted, but we're gonna call it good. Y equals 2 minus x. There we go. So when you want to find the area between the curves, you have to find the height of the region. So height is like this line, and this line. And this line can be found from the bigger radius, which is 2 minus x, and the smaller radius, which is this much, which is x squared. So what you do is integrating from this point to this point to this point to this point. Wait, let's try it. Let's try it again. This point to this point, and subtracting from the bigger height, which is the orange line, which is 2 minus x, minus the smaller radius, which is x squared, dx. If you look at our answer choice, you didn't get rid of B, C, E. There we go. We're just left with A and D, and we have to find the bounds. So when you want to find the bounds, what you do is set the equations equal to each other to find the intersection point. So you set x squared equals 2 minus x, then this becomes x squared plus x minus 2 equals 0, x plus 2, x minus 1 equals 0, x becomes 1 and negative 2. So this is from negative 2 to 1. So the answer for this question is A. Okay, so this question asks find the area bounded by the curves y equals 2 minus x squared and y equals absolute value of x. Y equals 2 minus x squared, and I'm going to write that in red, sorry. Y equals 2 minus x squared and y equals x absolute value. Let's draw it. So this line will be y equals x absolute value, and y equals 2 minus x squared is this line. So we want to find the area between those two curves, this much. So what we want to do first is find the intersection points. When you want to find the intersection points, you have to set those equations equal to each other, meaning this will become 2 minus x squared equal to x absolute value. What I'm going to do is I'm going to square the values. I don't have to deal with the absolute value of like plus minus signs. So I'm gonna square the values. X to the fourth power minus 4x squared plus 4 is equal to x squared. X to the fourth power minus 5x squared plus 4 is 0. X squared minus 4. X squared minus 1 is equal to 0. X squared is 4. X squared is 1. X becomes plus minus 2. X becomes plus minus 1. So now let's plug in the values to see which interval is actually above the x-axis. Let's plug it in 2. 2, if you plug it in, then this will be y equals 2 minus 2 squared. So this is negative 2, meaning the 2 will be here and negative 2 will be somewhere around here. Negative 2. So this is not actually the region that, this is not the bound that we want. So 2 is not right. If you plug in negative 2, y equals 2 minus negative 2 squared, this also becomes negative 2, which is not greater than 0. So these are not the value that we want. We want x equals plus minus 1. That as our intervals. So we have that. So this is from negative 1 to 1. But, okay, we have that. And what we can do is we can either like separate the region, or we can just like multiply 2 because they're both looking symmetrical. I kind of drew a little like looking not symmetrical, but if you draw it like correctly, it should look symmetrical because y equals x actual value is looking like a symmetrical shape. That's why it is symmetrical. So what I'm gonna do is find the height of the area between the region. So let's find the height of here, like this line. So if you want to find that height, the orange line, first we have to identify which is the bigger height. The bigger height is this line, which is 2 minus x squared. And this is 2 minus x squared. And this is, and you have to find a smaller height, which is this line, which is just x, because it's in the first quadrant. So if you want to find the height of this orange line, this just height becomes 2 minus x squared minus x, right? So the area of the region is 2 times, it's from 0, because it's 0 line, 0 to 1, because we said it's 1 for our intersection point, 0 to 1, 2 minus x squared minus x dx, and we multiply by 2 because we want to originally find negative 1 to 1. If you don't want to multiply 2, what you can do is negative 1 to 0, 2 minus x squared minus x dx plus 0 to 1, 2 minus x squared minus x dx. But this is a lot of calculations, so I'm just going to merge everything and just multiply by 2. So this is 0 to 1, and it's 2x. Actually, it's not right, the integral sign. So just 2x minus x cubed over 3 minus x squared over 2, 0 to 1, multiply entire thing by 2. This becomes 2 minus 8 over 3 minus 2. And if you plug in 0, this all becomes 0. So this becomes 2 times, negative 2 and 2 cancels out. 2 times negative 8 over 3 becomes negative 16 over 3. What did I do wrong? Oh, it's 1 over 2, never mind. I did the calculation wrong, didn't I? Sorry. So 2, like if you plug it in 1, 2 x 2 minus 1 over 3. Yeah, I did totally wrong, sorry. 2 minus 1 over 3 minus 1 over 2. And then you do the calculation and multiply by 2. So this becomes 6 over 12 minus 4 over, well, not 4, I am so sorry, 2 over 3 minus 3 over 6. This just becomes 7 over 6, and then you multiply by 2, this becomes 7 over 3. So we have the area as 7 over 3, which is D. Okay, so this question asks use cylindrical shells to find the formula for the volume of the following solid. Let's draw the region first. Y equals x squared. Oh, That's a little looking weird. Let's redraw it. Y equals x squared, y equals 1, and it's revolving around the line y equals 3, like this. And if you remember the cylindrical shells, when you choose dx or dy, it should be parallel to the revolving axis. Since our line is y equals 3, it's going to be revolving around parallel to this line, meaning it's going to be dy. So we use dy, get rid of the axis. And our region is this line. So let's find the volume of that region. And before we do that, if you remember the cylindrical shell method, it's volume equals 2 pi radius height dy. So let's first find our height. Height is this much, right? This line is, since we're doing in dy, this is x equals square root of y, and this is x equals negative square root of y. It's the reason it's a positive sign because it's the x-axis is positive in the first quadrant and it's negative in the second quadrant. That's why. So we have that. So if you want to find this line, this is square root of y, right? So square root of y to 0. And this is also negative square root of y to 0. So this is also square root of y. So the height of this line is square root of y plus square root of y. So it's 2 square root of y. So it's 2 square root of y. Okay, we have that. And our radius. Let's find our radius. So radius is, this is 3. And this is y. And we want to find this much, right? Which is 3 minus y. So our radius is 3 minus y. Radius 3 minus y, height is 2 square root of y. So we have everything. B is equal to 2 pi, 3 minus y, 2 square root of y, dy, revolving around, since it's area from 0, y equals 0, axis, to y equals 1, it's from 0 to 1. So 2 pi, 0 to 1, 3 minus y, 2 square root of y, dy, and we can take it out 2 in front of it. This becomes 4 pi, 0 to 1, 3 minus y, square root of y, dy. And square root of y can be written as y 1/2. So the answer for this question is C. Okay, so this question asks how much work is required to stretch it from its natural length into its disposition. So when you want to find the work is force times distance, and yeah, integral. So we want to find the force equation first, right? So force equation is the k constant that we don't know times x. It is the difference of, lengths. So we are given the force is 12N, and k we don't know, and we know that it's 0.1 meter longer, so it's 0.1. So if you want to find the k becomes 120 Newton per meter. We have that, so we can write force equation as 120x. Okay, we have that equation, and then the work is deriving from the force equation, and the x, the height, the distance, and it's from 0 to 0.1. So you can write this as 60x squared, integrating from 0 to 0.1, 60 0.1 squared minus 60 0 squared. This just becomes 0.6, so the answer for this question becomes A. Okay, what is the average value of the function fx equals sine cube x over the interval 0 to pi? Okay, so whenever you want to find the average value, this becomes 1 over b minus a to b interval, and then fx dx. And it's from 0 to pi, and its b is our pi, so this becomes 1 over pi minus 0 sine cube x dx. So 1 over pi, 0 to pi, and you can split sine cube x as sine squared x, sine x dx. And if you remember your trig identity, sine squared x plus cosine squared x is 1, and sine squared x can be written as 1 minus cosine squared x. So this becomes 1 over pi, 0 to pi, 1 minus cosine squared x sine x dx. And you can put u as cosine x because we see sine x dx can be derived from, it is a derivative of cosine x with the negative sign. So you can put u as cosine x and du as negative sine x dx. So 1 over pi, 1 minus u squared, negative du, and you have to find our new bound. Cosine 0 is 1, cosine pi is negative 1, so this becomes 1 to negative 1, which we can change our bound by putting the negative sign. We already see the negative sign, so you can write it as 1 over pi, negative 1 to 1, 1 minus u squared du. This becomes 1 over pi, u minus u cubed over 3, 1 to negative 1. 1 over pi, 1 minus 1 over 3, minus 1 plus 1 over 3. So this becomes 1 over pi, 2 over 3 plus 1 minus 1 over 3. This becomes 1 over pi, and so 4 over 3. So this becomes 4 over 3 pi, which is B. Okay, so this question has compute 0 to pi over 4, tangent x and secant cube x dx. So we can split the secant cube x into, I'm going to rewrite it, 0 to pi over 4 tangent x, secant squared x, and secant x dx. And what you can do is you can put u as secant x, and then you can put you can find the derivative of that as like secant x tangent x dx. The only reason that we are using secant as our derivative is because we see secant x and tangent x, and you can easily find it by using the derivative. So what you're going to do is put u equals secant x. You can find the derivative of that, becomes secant x tangent x dx. So that's our du, and you have to find a new bound, which is secant 0, which is 0, secant pi over 4, this just becomes square root of 2. So now that you have those, you can write it as 1 to square root of 2, u squared du. This becomes u cubed over 3, 1 to square root of 2. If you do the integration, 2 square root of 2 over 3 minus 1 over 3. So this is just E. So the answer for this question is E. Okay, so this question has find the volume of the solid that results from rotating the area between the curves y squared equals x minus 1 and y equals x minus 1. Y equals x minus 1. You can write this as y squared plus 1 equals x and y plus 1 equals x. And let's draw it now. You can draw it as y squared plus 1 like this and y plus 1 like this. So this is the region of the area, and whenever you find the volume of it, you have to find the height or the radius, like this yellow orange line. You need to find those like lines to find the volume. I'm gonna use the dishwasher method for this question because I think it's easier. So the volume of the dishwasher method is pi bigger radius squared minus smaller radius squared. So the volume is pi bigger radius, which is further down to the right, which is this line, which is y plus 1. So y plus 1 squared minus smaller radius, which is the curved line, y squared plus 1 squared dy. So we have that, and then now you have to find the bounds. So whenever you want to find the bounds, it's the intersection point, meaning you have to set them equal to each other. So y plus 1 equals y squared plus 1. 1 cancels out. Y squared minus y is equal to 0. Y minus 1 equal to 0. Y becomes 0 to 1. So 0 to 1. So it's from pi 0 to 1, y squared plus 2y plus 1 minus y to the fourth power plus 2y squared plus y dy. And then it's from pi 0 to 1, y squared plus 2y plus 1 minus y cubed, y to the fourth power minus 2y squared minus 1 dy. 1 and negative 1, 1 and negative 1 cancels out. So pi 0 to 1 and negative y to the fourth power, y squared and negative 2y squared can be cancelled out as negative y squared, and plus 2y dy. And then if you do the calculation, negative y to the fifth over 5 minus negative y to the third over 3 plus y squared, integrated from 0 to 1 and multiplied by pi. This becomes negative 1 over 5, negative 1 over 3 plus 1. So pi 15 minus 3 minus 5. So this becomes 7 pi over 15. So the answer for this question is B. Okay, so this question asks find cosine x over 4 over e to the x dx. So it is cosine x over 4 e to the negative x dx. You can rewrite it as like that. So if you remember our integration by parts, you often write LIAT, which is logarithmic, inverse trig, algebraic, trig, and exponential. Like in this left order, you choose u, and you'll most likely choose u as our cosine x over 4. But this is the very rare case that you have to choose u as our exponential, because some of the exponential questions will make you to choose u as exponential because it might just make you to do like calculation forever, which is why you have to choose the right u. In this case, our u is e to the negative x. And our derivative for this is negative e to the negative x dx. And our dv would be cosine x over 4 dx. And our b becomes 4 sine x over 4. And if you remember the integration by parts formula, it's ub minus b du. E to the negative x, 4 sine x over 4 minus 4 sine x over 4, and then minus e to negative x dx. Since we both have negative sign, we can write it as 4 e to negative x sine x over 4 plus 4 sine x over 4 e to negative x dx. So we have that, and since we have to do again for the integration by parts, we're going to do it again, and we're going to put the u as also e to negative x, and du would be the same thing, negative e to the negative x dx. Our db would be 4 sine x over 4 dx, so our b becomes negative 16 cosine x over 4. We have that. Okay, so now you use the ub minus b du formula again. So e to the negative x minus 16 cosine x over 4 minus 16 cosine x over 4 minus e to the negative x dx. Yay, we have that. And since we have negative sign, this becomes positive 16 cosine x over 4 e to negative x dx minus 16 e to negative x cosine x over 4. But if you remember our original formula, it also has cosine x over 4 e to negative x dx in our original formula, right? So what we're going to do is you're going to set like all the values that you got, this value and this value, equal to the original this value. So okay, let's write it. This is a lot of mess. So we have this part from our first equation, 4 e to negative x sine x over 4, and then we have this part from the second integration by parts, which is negative 16 e to negative x cosine x over 4 minus 16 cosine x over 4 e to negative x ds. I took out negative 16 out of the equation, and this is equal to cosine x over 4 e to negative x dx. Since they're like the same thing, you can put this value as I. I equals cosine x over 4 e to the negative x dx, because we don't want to write it over and over again. This is just for my convenience sake. So this becomes I equals 4 e to the negative x sine x over 4 minus 16 e to the negative x cosine x over 4 minus 16i, right? And then you can move the negative 16i to the right, to the left side. This becomes 17i equals 4 e to the negative x sine x over 4 minus 16 e to the negative x cosine x over 4. And you can divide 17 in both sides. This becomes I equals 4e negative x sine x over 4 minus 16 e to the negative x cosine x over 4 over 17. So we have options as those. So we see 15. So 15 is not right for our answers. And so it's going to be either B or E. But if you remember it, it's 4e negative x sine over 4x negative 16e to negative x cosine x over 4. And it looks a little different. So we can make it similar to our like answer format. So e to the x, negative x, can be going into like the denominator. So we can put, let's group it first, actually. Let's group it, e to the negative x. So let's group the e to the negative x in the denominator. This becomes e to the negative x, 4 sine x over 4, and minus 16 cosine x over 4, over 17. And since e to the negative x has negative sign in front of the power, you can put it as denominator and get rid of the power. So this becomes 4 sine x over 4 minus 16 cosine x over 4 over 17 e to the x, which is equal to our answer choice B. So the answer for this question is B.